Thank you. So I'm here to talk about OpenAPI and how it makes using or even creating HTTP APIs easy in Julia. Um, so I'll start with the OpenAPI basics, a little bit about OpenAPI itself, what it tries to solve, and what are its goals. Then I'll switch to OpenAPI.jl, what we have in Julia, and where things are and what we should use. Then I will get into some demo where we'll actually see the details. And finally, we should have time to summarize and have some questions and answers. So so about OpenAPI. So OpenAPI is actually a specification, an interface specification for HTTP APIs. It is similar to REST if you have used REST. So it has, so similar to REST, it has services which are services on resources, and resources have properties, and actions can act on resources. They can create resources, delete resources, or update its attributes, properties. So this is REST, and OpenAPI is very similar. It just puts a structure to it, right? It is programming language agnostic, similar to REST. So the goal of the specification is to make a service discoverable and easy to understand without actually using it, right? So as a user of the service, you can look at the spec and see what it does. As a provider of the service, you can give the spec to, you can publish the spec for your users so they can use it easily. So that is primarily the goal of OpenAPI. OpenAPI also has a set of tools. So when we say OpenAPI, we mean the specification and also the tools around it. So the most popular tools are probably the tools from Swagger, because they were the initial creators of the spec, and they contributed the spec to the OpenAPI initiative. But now there are a lot of OpenAPI tools available. So there are very good ones also around. So So to summarize, OpenAPI is the specification and the tools around it, and the USP, so to say, of OpenAPI is the simplicity it brings, because of it's based on REST. It is very widely understood and it is simple. And compared to the other things out there like gRPC, GraphQL, and SOAP maybe, OpenAPI is more general purpose. And so unless you need something that the other protocols are bringing in, you're probably better off using OpenAPI, and it is simpler that way. Yeah. A little bit about how the specification looks. The spec is a JSON file or JSON-like file. So it could be a YAML, for example, or it could be JSON. It has sections for servers, which mention where the API can be found. It has tags, which let us categorize the APIs into different types of APIs. And then the APIs themselves. APIs are basically paths, the resource path, and the methods that act on it. The methods may take parameters, and they have responses. And it lets us create components out of the things there, of the parameters and responses and methods, so that we can reuse them as modules. So we shall see some more details. Let's see one example of, I guess, something happened. I'm sorry, I just sign in, maybe then it'll work. Oh, sorry, what is this? Did I sign in? No. Okay. Oh yeah, there you go. So this is a sample OpenAPI spec of something that's an example pet store. So it says it is OpenAPI version 3, and there is a section for information where we can have some description, title, and some license information and such. There is an explicit section for docs, and this is where we specify where the service can be found. The service URL can either be a full URL including the host name, or it can be a relative URL, in which case when you invoke it, you need to specify where it is actually. These are the tags. So we have 3 types of APIs here. One related to pet, one is the store API, and then there can be user-related APIs. And these are the APIs, which are paths, and there is a path for the pet resource, and there is a put action on it. It belongs to the pet class of APIs. And this is the request parameter, and these are the responses possible. Now, here you see that the request is actually a reference to a component. So it is referring to a component that is described here. And the responses are simple. They do not, it is not defined what they return. They probably just return the status code. This is just an example of that. We will find many varieties. For example, the response here says that the response can be XML, and this is the schema of the XML, right? Or it can be JSON, and this is the schema of that JSON, right? So there are a lot of things that can be specified in the spec. Not all are mandatory. So you can implement something very simple and use OpenAPI, or you can implement something very detailed and use it equally well, right? All right. So now back to this. Okay, so now let's see some more details about the Julia package. So the Julia package is actually in 2 parts. One is the code generator, and the other part is the Julia package itself. The code generator is not written in Julia. So it is a generator which applies to all languages which implement OpenAPI, and it's actually a Java program, and we have a module there, plugin there implemented for Julia. So if you run the code generator and specify Julia as the language, it is going to output Julia code, but it itself is not written in Julia. That aside, the code that it generates uses the OpenAPI.jl package, because the protocol implementation for Julia is in OpenAPI.jl package. So the generated code makes use of this package, and you'll need it even while running the code, right? We have an older implementation of OpenAPI.jl, which is the Swagger.jl package. It is deprecated. So Swagger.jl is the OpenAPI version 2 implementation, but version 3 onwards we use OpenAPI.jl, and OpenAPI.jl is backward compatible. It will work with version 2 specs as well, right? So this is what we have for the Julia code generator. Now I have mentioned few other packages as well here, which are the API integrations. They are the things that are generated using OpenAPI.jl. I just thought I should mention it here because these are like very large specifications. Kuber.jl is the Kubernetes API, which is the cloud implementation for Kubernetes, and it is entirely generated using OpenAPI. We have Azure.jl, which is the client for Azure Cloud. Similarly, we have packages for Slack, GitHub. So just to say, we already have existing packages which use OpenAPI in Julia. All right, some more details of the code generator I have already mentioned. So it is actually in this repo. The code generator is in this repo. It has very good documentation, and you could go through it and install it locally. And if you want to contribute, then the Julia specific plugin is in these sources. So in case you are interested in contributing, this is where you should look at. You could download and install this locally, but you don't need to, because OpenAPI.jl has a way to invoke the generator and other tools from Julia itself. So it has a way to have Docker containers installed locally for all the services, and you can make use of that. So we are going to primarily use those in the demo today. Yeah, a little bit on the way the generated code is organized. So the code is generated as Julia module, and it also gets the documents generated for the APIs. So it will make use of the descriptions and the parameter types and the details there to generate docs. It is structured similar to a Julia package. So there will be a source folder which will have the sources. There will be docs folder which will have the docs. You can register this as a Julia package if you just add a project.tom element. All right. So it is structured like that. It will even have a README, which is pointing to the docs and other stuff. The client modules are complete. That is, you can use it straight away. It is based on downloads.jl for the HTTP client part, and they are complete and they can be used. But the server modules obviously will need the implementation of the logic, the server-side functions, right? And the server module is based on http.jl, which has the server implementation of HTTP in Julia. We shall see actual code generated as we go further. All right, so now we can actually see some demos. This one says good. Yeah. A little more? All right, we'll actually be mostly using the Jupyter lab, so I should increase the font size here. Is this okay? Yeah. It's probably too much, but it's all right. Yeah. Let me close. Okay, so we shall have two parts to the demo. To start with, we shall look at a specification and generate a client out of the specification, because I feel that is the most common thing that we would most likely do, because we have some HTTP service which has published a spec. We want to use it, so we want to generate a client and then use it straight away. Right? We shall look at that, and then we shall have another example where we implement the service on our own. So we write a spec, we implement the server and use the client, and it will be end-to-end demo, right? So let's start with the first one. So here I'm going to use GitHub as an example. So GitHub publishes its OpenAPI as a OpenAPI spec. We're going to fetch it. We're going to see briefly, but it's a huge spec, so we're going to see a part of it. We are going to generate Julia client package for that, and we'll also see the generated code, and we'll use it. All right. So let's clean up. We are going to use these packages, downloads, OpenAPI, and JSON. Fetch the spec. It's already there, so it's actually not getting it right now. We already have it. Okay, let's examine the spec. To examine the spec, I'm going to use something tool called Swagger UI. So I can start it from OpenAPI like this. I call OpenAPI Swagger UI and pass a spec. It is going to launch a Docker container on my machine, and it's going to open a URL like this. If I click on that, I get this browser UI, and this renders the spec in a nice HTTP GUI. So I see GitHub has all these APIs, and these are the API classes. So there is a class for action, there is an API class for activity, apps, billing. It's a lot of API. All right. So there are close to 500 or 600 APIs here. Let's look at one of these. Let's go to the first one. So this is the API set to manage GitHub Actions using REST API. The first one is to get GitHub Actions cache usage, right? So there is some description, and there is some pointer to more documentation, and it shows what parameters I can pass and what responses I can expect. So this is the struct I can expect, and it lets me try it out too. So if I click on this button and I have everything hooked up, my authentication tokens and everything, I can actually pass some parameter here and execute and get the result, right? So this is what the Swagger UI tool provides. So let's stop that and let's generate code for it. So I start another service, which is the OpenAPI-generator, and then I can now call it from Julia. So I pass my spec to it and ask it to generate a client. So it is going to send the spec to the service. Service is going to churn out source code, and we are going to get the source code here. It's a huge spec file, so it takes a little while to generate the whole thing, but we should be there soon. All right, we have it. I'm going to stop the generator. And as I mentioned, it is structured like a Julia package. We have source, we have docs, README, and inside source, this is the main module. It can be registered as a package also. Now let's try and use it. I'm going to include the main module. Then to use the client, I have to create a client instance of the API set I'm interested in. So we saw there are many API sets in the GitHub spec. I'm interested in the repos API, let's say. So I'm going to create a client for the repos API. And once I have the client, I can invoke an API on it, invoke a method on it. So I'm interested in the repos get method, which gets the details of a repo. So I'm going to query for details of the Julia repo, which is there in the Julia Lang org, right? So if I execute that, it's going to go to GitHub API service and is pulling out details of Julia repo. And the results are there are a lot of details I've got, and it is in the form of a Julia struct, right? And I can access the struct. And let's see how many stars the Julia repo has. It has close to 45,000 stars, which is great. All right, so in this demo, we picked up a spec, we generated a client and used it in a very short time. Next, let's try and define our own spec. For that, I have a simple prime number service from which I'm going to generate client and server, right? So clean up, and let's launch the spec editor. Now, similar to the viewer, we also have a tool to edit the spec, right? So I can call that from the URL it publishes. I have already passed an initial file to it, which has the spec. My spec was here. It is going to display an editor for that spec. So here, this is the spec I have created. I have one resource, one action, which is API call to generate prime numbers in a range of numbers. And I'm going to pass a request, which is the request parameter, which is the range in which I want to generate the primes. And I'm going to get a response, which are the prime numbers in that range. And the request is um, is an object which has two attributes, from and to, right? They both are integers, and the response is an array of integers, right? So I just have one API in this, right? And this editor lets me edit the code live. So like if I change something here, it will reflect in the view, and I can use it for live editing and testing the spec. Once I have edited and saved, I can go ahead and generate code out of that. So I invoke the same code generator, and this time I am asking it to generate both the client and the server. And that's done. And let's stop the generator. Let's move to the server. First, let's implement the server. All right, so this is my server. Here, if I look at the code generated for the server, this is the main module, and the docs ask me to implement this method. The following server methods must be implemented, and I need to implement this method, right? Generating range, which takes this request and has to give an output like this. So let's try and do that here. So I'm going to need the primes package. We have already seen the files it generates, and let's load the module. And this is the method that I have implemented, right? It's the same signature. I get a request which has the range of numbers. I call the primes method from the primes package, and I get a list of primes which I send back, right? So I implement this method, and then I register the module in which my method is present, right? Which is this current module. I pass it to the server to register, and my router is set up. I can run a HTTP server using the router, and my server is up, right? So now let's go back to the client. So this is a client. I'm sorry. This is the notebook. Yeah. So it's very similar to the GitHub client that we saw. We start using OpenAPI, include the client module, create an API instance, create the request, which is the range in which I want the prime numbers from 5 to 20, and call a Julia method to list the primes. And I should get a vector of numbers in that range. So yeah, so we implemented a server and a client, and we defined our own spec. Okay, so to summarize, OpenAPI is a great way to specify HTTP APIs, and the tools around it make it very easy to create services or consume services. And in OpenAPI.jl, we have a plugin to the OpenAPI code generator for Julia, and hopefully we'll see a lot of usage of that in consuming HTTP services or building HTTP APIs. Yeah, that's all I have. Thank you.
Any questions?
What is the current support for authentication when you're auto-generating a client?
Yeah, that's a good question. OpenAPI spec allows authentications to be specified in the spec, but not everything is implemented yet in Julia. So we do not do anything directly. But what we provide are hooks to for the client to set headers or get hooks at different points in the client. So if you have a token, for example, you want to authenticate, after creating the OpenAPI client, you could set your token as headers in that client, and all your APIs will start using that token. And similarly, on the server side, we have a way to hook into different stages of the server. For example, when the request arrives, you can get yourself called, get your code called after the request is parsed and at different stages. So you could implement any kind of authentication you want, depending upon where you have the authentication information present. If it's in certificates or in the headers or in the body, you could implement it there.
I have just one little question. It wasn't quite clear. So in your prime example for the server, if you add new endpoints or modify the response or anything like that, and I regenerate the code, does it regenerate over top of what I've done? Does it do it in addition to? Like, how smart is the code gen?
Yeah, so the way the code is generated will not overwrite the code that you wrote, because it is generated as a module, server module, and you register the module that you have implemented the code in. That's a separate module, and so they are separate. So yes, it will override the code, but the code that it itself generated. So yeah, it will not override the code that the user has written.
Yeah, I have one small question also. I see you have already implemented Azure.jl, but do you have any plans on AWS.jl implementation maybe?
The thing is, AWS.jl does not publish OpenAPI spec for whatever reason. It's probably, I don't know. It does not have a, but if it had, we could probably have generated.
Okay,
Yeah,
okay,
yeah.
I see, thank you.
That's a good question, because AWS is very popular.
Can you mix and match generating different languages? Like maybe I make the server in JavaScript and the client in Julia.
Oh, yeah.
You can, yeah. Okay.
Yes,
Okay.
certainly, yeah, because the protocol is language agnostic. You can have servers in any language and clients in any language. Even the generator, yeah.
Yeah, I think it was a really great talk. Thank you. A round of applause for our speaker.
Thank you.